Hello and welcome to all. Myself, Dr. Sherin Antony. I'm an assistant professor in Bharatmata College, Stukakara, and I'm in the Department of Zoology. My topic is Simpson's Diversity Index. It is a tool to calculate the biodiversity. So let us have a look at the PPT, Simpson's Diversity Index. So what is biodiversity? Biodiversity is the variety and variability of life on Earth. It is the different kinds of plants and animals which are present on the Earth. And a high level of biodiversity, it is usually considered to be important and desirable. So you all might have heard about a biodiversity loss. That is when there is a decrease in the diversity of organisms present in the Earth. And this biodiversity loss has been one of the main global environmental issues. And nowadays, a lot of research and studies have been done in order to understand the consequences of biodiversity loss on the ecosystem and the society. So, in the biodiversity, mainly two things are into consideration. One is species richness and the other is evenness. So what is species richness? It can be simplified in this diagram. As you can see, richness on the left side, you can see richness means the number of different species present. So here you can see there are three different kinds of organisms. So as the number of different kinds increases, the species richness also increases. And on the right side of the slide, you can see it is concerned with evenness. So if a habitat or a place has similar abundance for each species present, the habitat is said to have evenness. So here you can see there are only two kinds of organisms on the right hand side and they are evenly distributed. That means each kind of organisms is represented by four. The first organism, you can see the four organisms are present, and the second organism, there are only four representatives. So as the greatest evenness, as the two populations have similar abundance. So let us move on to the calculation of biodiversity using a tool called Simpson's Diversity Index. So as I said earlier, Simpson's Diversity Index measures the diversity of a community. It is commonly used to measure diversity, and the value of Simpson's diversity ranges from 0 to 1, where high score, that is closer to 1, indicates high diversity and a low score indicates low diversity. What are the applications of this Simpson's Diversity Index? The useful aspects of the diversity is to compare two sets of data to see which habitat is more diverse. For example, if one has a diversity index of 0.5 and another has a diversity index of 0.35, then the set with highest diversity index, that is 0.5, is more diverse. So let us see how this diversity index is calculated. It is very simple equation. The diversity index is denoted by the capital letter D. D equals 1 minus sigma small n into n minus 1 divided by capital N into n minus 1. So let us have a look at what does small n and capital N denotes. Small n is the number of individuals of each species, whereas capital N, it is the total number of individuals of all species present in a particular area. So let us have a sample question. From the data provided, let us calculate the Simpson's Diversity Index. Here in the table, you can see 5 different species are numbered, and on the right hand side, each species number is provided. So as we add on the number of individuals of different species, we get a value of 89. So what does this 89 shows? 89 is the value of capital N. That is the total number of individuals of all species present in a habitat. So let us move on to further calculation. So in the step 1, insert the total number we got, that is 89, into the formula capital N into N minus 1. So by equating this, we get a value of 7,832. So this 7832 is the value of N into N minus 1. So put this number aside for a moment. Let's move to step 2. Step 2, we have to calculate small n into n minus 1 and we have to sum it up. So we have to subtract the number of species and subtract it from 1. So in the table shown here, you can see the value of n minus 1 is shown, and on the right hand side, you can see n into n minus 1 is shown. So let's have a look at the species number 1. It shows 81 individuals and n minus 1 means 81 minus 1, that is 80. And on the right hand side, you can see small n into n minus 1. So 80 into 81, we get an answer of 6480. So as we sum up the small n into n minus 1 value, we get the sigma n into n minus 1, and the value is provided here, that is 6488. So by substituting the values, we get Simpson's diversity indexity. Simpson's diversity index D is equal to 1 minus sigma n into n minus 1 divided by capital N into n minus 1. And here we get the answer, D is equal to 0.17. So the diversity index for this particular set, what we got is 0.17. If for a second sample from another area, we analyze the biodiversity and what we got as value is 0.5. What does that mean? This means that compared to the previous one that was 0.17, this is 0.5. This means that the second sample diversity is much more. So what we all saw in the first slide was that higher score close to 1 indicates higher diversity, whereas lower score close to 0 indicates low diversity. So as the value of D increases, the biodiversity also increases. So simply we can say the second sample with more value of D is more diverse than the first sample. And so the biodiversity keeps the ecosystem at an equilibrium. And as we all know, the biodiversity or the variety of plants and animals are being threatened by a lot of problems like climate changes, pollution, overexploitation of natural resources, and obviously habitat loss. So what we have to do is we have to conserve the biodiversity. So the biodiversity we experience today is the result of billions of years of evolution. So to effectively promote ecosystem conservation, an integrated management of natural resources is needed. So let's all play our role in conserving the biodiversity. Thank you all once again. Thank you. So that was all my video. Thank you all.